In this video, we're going to take a look at angles with parallel lines. So let's start with some parallel lines. Now those look parallel. If you really want to communicate that they are in fact parallel, you can use these arrow marks to show that they are in fact parallel. Now to get some angles here, we need a third line that intersects. This third line is often referred to as a transversal. Now let's take a look at the angles. You should be able to see that there are 8 angles that are formed with these parallel lines and the transversal. There's 4 acute angles and 4 obtuse angles. It turns out that all of the acute angles are equal. It does look that way. So we could mark it that this angle is the same as that angle, and it's equal to that one and that one. It also follows that all of the obtuse angles are equal to each other. So this angle is the same as that one, and that one, and that one. Now it's time to take a look at what are the actual names that we can give to certain pairs of angles in this diagram. You're going to want to take notes on these different names we have for the different angles in this diagram. So go ahead and pause the video and put this diagram on your paper with all these angles numbered. All right, we're going to start with corresponding angles. So corresponding angles are equal. And a way that we could describe what the corresponding angles are, they're in the same positions if the top group of angles overlapped with the bottom group of angles. So if we put the top group right on top of the bottom, you should notice that angle 1 and angle 5 are in the same position. So we're going to write that angle 1 is congruent to angle 5. Next up, angle 2 and angle 6 are in the same position. So let's write angle 2 is congruent to angle 6. Next, we would have angle 3 and angle 7. And finally, angle 4 and angle 8 are congruent. So if you're given a problem, and for example, they tell you that angle 2 is 70 degrees, and they want to know what angle 6 is, you would use corresponding angles as your reason for saying that angle 2 and angle 6 are congruent, which means they would measure the same number of degrees. Next up, we have alternate interior angles. Continue to pause the video whenever you need to make sure you get all this information down as notes. Because when you get problems like these, you're going to be using your notes until you've memorized everything. So alternate interior angles are equal. They are inside of the parallel lines. That's why they're called interior. And then the alternate part of the name refers to one of them being on the left and one of them being on the right. So for example, angle 3 would match up with angle 6. And the reason is they're inside the parallel lines, and one's on the left, one's on the right. Just so you know, angle 3 and angle 4, those aren't alternate interior. I know they're inside the parallel lines, and one's on the left and one's on the right, but they're not using the parallel lines. 3 and 4 would just be line equals 180, or a linear pair. So those don't count as alternate interior. So let's write angle 3 is congruent to angle 6, and then the second pair would be angle 4 and angle 5. So go ahead and write that, and you've got your notes on alternate interior angles. Next up, we're moving to the outside. Guess what those are going to be called? Now, we will look at alternate exterior angles. And these are also equal. And you might guess what this means. They're just like alternate interior, except instead of inside the parallel lines, these are outside of the parallel lines. They still alternate, so one will be on the left and one will be on the right. So one example would be angle 1 is alternate exterior with angle 8. So let's write angle 1 is congruent to angle 8. And the second pair of alternate exterior angles would be angle 2 and angle 7. So those are our alternate exterior angles. Now we're going to move back inside the parallel lines with a pair of angles that are called consecutive interior angles, but they can also be referred to as same side interior angles. And these angles are supplementary, which means they add up to 180 degrees. Now, since they're interior angles, they are inside of the parallel lines, but instead of alternating, they're on the same side of the transversal line. So one example of this would be angle 3 and angle 5. So we can write the measure of angle 3 plus the measure of angle 5 equals 180 degrees. Now you might notice that unlike the first view we looked at, I wrote that M in front of the angle, and instead of congruent, I wrote equal. So the reason for this is if you talk about the number of degrees, the measurement of something, that's something that we use equal for. Whereas if we say that two angles have the same exact shape, then we can use congruent. So that's why I use congruent for corresponding and alternate interior and alternate exterior. But when we want to define what's going on with consecutive interior, we want to talk about that they add up to 180 degrees. So that's why you can see that M, which refers to the number of degrees. So the degrees of angle 3 plus the degrees of angle 5 add up to 180 degrees. The other pair of consecutive or same side interior angles would be angle 4 and angle 6. So we can write the measure of angle 4 plus the measure of angle 6 equals 180 degrees. By writing it this way, it will help us set up our equations when we have to solve for variables. Instead of simply saying that angle 3 and angle 5 are consecutive interior or same side interior, I would rather you just always write angle 3 plus angle 5 equals 180 degrees. Now we're going to move back outside with the same idea. The last angle relationship that we'll look at in this video is consecutive or same side exterior angles. And just like the consecutive interior angles, these are supplementary, which means they add up to 180 degrees. Since they're exterior, they'll be outside of the parallel lines, and since they are same side or consecutive, they're on the same side of the transversal line. So we could start with angle 1, which is consecutive exterior with angle 7. So the measure of angle 1 plus the measure of angle 7 equals 180 degrees. And our last pair of same side exterior would be angle 2 and angle 8. So we can write the measure of angle 2 plus the measure of angle 8 equals 180 degrees. That is all the different type of angle relationships we have when a transversal intersects two parallel lines. So on the right side here is a typical type of problem that you'll solve with these angle relationships. When given this problem, you would want to give your reason, or the type of relationship it is, and then you would write an equation, and then you would solve for your variable. So go ahead and give it a try. So the way that you'd be using your notes on this is you'd want to realize that the 140 degrees matches up with angle 3, and the x matches up with angle 5. And then as you search your notes, angle 3 and angle 5 are listed under consecutive interior angles. And consecutive interior angles equal 180 degrees. So that's our reason. Notice I abbreviate most of these things. The next step is to go ahead and write our equation, which in this case is x plus 140 equals 180. This is why I like to identify the justification as consecutive interior angles equal 180 degrees instead of simply writing consecutive interior angles. Finally, we would subtract 140 from both sides and get x equals 40. Now, if you were kind of bothered by the fact that in our problem, the 140 degrees is an obtuse angle, but in your notes, your angle 3 there is an acute angle. If that bothers you, there's a simple way you can solve that. So here it is. If you want your notes to match up more closely with any problem that you're given, you should have two versions of the numbered angles. In your second version, just have your transversal line lean to the left instead of leaning to the right. And then put in the same numbers, and then you should be prepared for any type of problem that you're given. By the way, if you're given a problem that looks like this, then all you've got to do is turn your paper sideways and you'll get a good match with either your diagram on the left or your diagram on the right. From there, you're just using your notes to match up the angles that you're given to find out what the relationship is between them. Now be careful, there are situations where you can get angles that don't match up with what you have. In that case, you'll just have to use two different reasons to solve what you're looking for. For example, if we had a problem that was asking about angle 4 and angle 7, that's not going to show up in your notes. So you'd have to take two steps. For example, you could say that angle 7 is the same as angle 3 because they are corresponding. And then angle 3 plus angle 4 equals 180 degrees because it's a linear pair, or line equals 180. There's many other ways that also work. You could have gone from 7 to 6. Those are vertical angles, and then used 4 and 6 as same side interior or consecutive interior equals 180. No matter what, angle 4 plus the measure of angle 7 equals 180 degrees. But there's a handful of different combinations you can use as your reason why. And that'll conclude our video on angles with parallel lines.